So next, you're asked to integrate secant square log x by x and sine root x by root x dx. So again, as you can see, this function secant square log x is some way made of log x, and you have the differentiation of log x 1 by x beside this. And here also root x differentiation is 1 by 2 root x. So in some way 1 by root x is there with you. So substitution method works. So whenever you look at substitution, you need to look for differentials. Log x's differentiation is 1 by x. The root x's differentiation is 1 by 2 root x. The constants can be adjusted. The function should be there. Some sort of function should be there. So here let log x is equal to t. So 1 by x dx is equal to dt. So this becomes integration of secant square of log x is t, and dx by x becomes dt. So integration of secant square t dt, that is equal to, so what is integration of secant square t dt? Tan t plus c. So once the integration is completed, you can do the back substitution. This t is nothing but log x. The answer is tan of log x plus c. So the integration of this is this. Similarly, if you want to integrate sine of root x, so we can let the root x be equal to t. This implies 1 by 2 root x dx is equal to dt. So dx by root x. So dx by root x can be written as 2 dt. So what does this integration become? Integration of sine of root x is t. So sine t into dx by root x is 2 dt. So 2 is a constant, it goes out. So 2 integration of sine t dt, that is 2 times minus cos t plus c. So once the integration is completed, you can do the back substitution. That is equal to minus 2 cos of root x plus c is the answer.